Hello everyone, welcome to ConceptsEra. Today we are going to discuss another caselet based upon letter decoding. We have discussed close to 5 caselets before this to make you understand how to approach caselets based upon letter decoding. So let's get started and try to understand what exactly given to us in this particular caselet and how we can approach this caselet. So in the given caselet, there are 8 distinct odd numbers from A to H. And these odd numbers we have to select from 11 to 49, and both of them are inclusive. Further, some information is given to us, and through that information we have to decode what alphabet is supposed to represent what particular number. So let's put the given data in better manner to decode this particular caselet. So here we go. Here we are having 8 letters and we have to decide what letter represents what number. So if you look at the first point here, the first point says there are 2 perfect squares. So we have to look for odd perfect squares between 11 and 49. If we look for odd perfect squares between 11 and 49, there are 2 perfect squares. Number 1 is 25 and number 2 is 49. Now if we read further, and A is higher of 2 squares. Now out of these 2 perfect squares, A has to be the higher one. So immediately we can say A is 49 here. So we can remove 49 from here because we already decoded letter A is representing 49. Other letters supposed to represent 25 because there are 2 perfect squares. Now look at statement 2. Statement 2 says C is perfect cube. When C is perfect cube, we have to look for odd perfect cube. So what is odd perfect cube? We can immediately say it comes out to be 27. So we have used 27. In the place of C, we can write down here 27. So we have decoded second statement also. Look at the third statement. B and E are prime numbers. There are multiple prime numbers between 11 and 49. So we will hold this particular statement. Now if you go for the fourth statement, they are saying both the digits of F are same. If we are looking for an odd number as well as both digits has to be same, there are only 2 odd numbers like that. One is 11 and other one is 33. Now if you look at fifth one, fifth it is given to us A minus C is equal to 2H. We know A from here, we know C from here. A is 49 and C is 27. So A minus C is 2H. So we can say 22 is equal to 2H. So H has to be 11. So we got from here H is equal to 11. So once you got H is 11, we can say F cannot be 11 from here. That means F has to be 33. So these numbers we have fixed from the given information. Let's move further and see. In 6th information, they are saying G, B, E have same unit digit. So all these 3 numbers are having same unit digit and all these numbers are odd. So we can decode what kind of the numbers it will be. If number is ending with 1, we can look for 21, 31 and 41 because 11 is not possible here. 11 is represented by H. Similarly, we can look for 13, 23 and 43. I cannot take 33 here because 33 is represented by F. If number is ending with 5, I cannot take here because we know from information 3, out of these 3 numbers, 2 numbers are prime numbers. And when number is ending with 5, that number cannot be prime number except 5. So we cannot take 5 here, so we have to move towards 7. So if number is ending with 7, we can write down 17, 37 and 47. I cannot take 27 here because 27 is represented by C. And finally we left with number which is ending with 9. So when number is ending with 9, we can write down 19, 29 and 39. So these are the possible cases and these are the possible numbers G, B, E can represent. Now if you see statement 8, statement A says difference between digits of G is 4 and difference between digits of B is 3. So if you see G, can we say out of these 3 numbers, one of them has to be G? and difference of digits has to be 4. You can see 21 difference is 1, 31 difference is 2, 41 difference is 3. So we can say from here these numbers cannot represent G. Similarly, if we go for second here, we know difference of digits of B is 3. If we see difference here, 3 minus 1 for 13 is 2, 3 minus 2 for 23 is 1, and 4 minus 3, which is 43, is 1. So immediately we can say there is no number here where difference of digits is 3. So we can remove this also. And if we look for the last part also, accordingly we can remove this because difference between digits of G is 4. Now if you see 19, 9 minus 1 is 8, no. 9 minus 2 for 29, it comes out to be 7, no. 9 minus 3 comes out to be 6, no. So immediately we can say these numbers are not possible. So we left with only this particular number. Now difference has to be 4 for G. So we have to look here what numbers are giving us difference of 4 here. So if we see for G, 37 difference is 4. Now for B difference has to be 3. We can see here 47 difference is 3. So we decoded here what number is representing G and what number is representing B. So G has to be 37 because difference between digits is 4. And B has to be 47 because difference between digits is 3. Now we have to see out of G, B, E what number is left out. We can see from here E is left out here. So remaining number has to be E. So 17 is E. Now finally we left with only one letter, which is D. And what is given to us about D? D is not a prime number from statement 7. As well it is given to us there are two perfect squares. Out of two perfect square, one is taken by A. That means left out number has to be D. So D has to be 25. So you can see how easily we decoded this particular caselet while reading the given information and connecting the given dots, which we were doing in previous 5 caselets. So let's move further and see questions based upon this particular caselet. So if you look at the first question here, the first question is if any three numbers are multiplied among A to H to get different numbers, then what is the difference between maximum and minimum possible numbers? So ultimately we have to multiply 3 maximum possible numbers and 3 minimum possible numbers, and we have to look for difference between those numbers. So we look for maximum possible number. So maximum possible number will be 49 into 47 into 37, and minimum possible number will be 11 into 17 into 25. So difference comes out to be 80536. That's the correct answer for this particular question. So after decoding, anyway, question always becomes easy. Look at next question based upon this particular caselet. The question is, Abhi selected half the numbers in the set such that exactly half of the selection has odd number of factors. If you recall our numbers classes, we know only perfect squares have odd number of factors. So definitely half of them he will be selecting perfect squares, because ultimately he wants to select these two numbers which are half. So 2 definitely are perfect squares. In how many ways he can do so? So ultimately what they're asking, try to understand, in his selection half of them are numbers are perfect squares and remaining half of the numbers are not perfect squares. So as we know, in the given numbers only 2 of them are perfect squares. It means he will be having 4 numbers. Out of 4 numbers, 2 of them are 49 and 25, and remaining 2 of them any other number which are not perfect squares. So we left with 6 numbers here, right? We left with 6 numbers here. How many ways we can choose 2 numbers out of 6 numbers? We can choose in 6 C2 ways, which comes out to be 15. So right answer for the second question is 15. I hope that you understood this particular question. If you have any doubt regarding any caselet, please feel free to put your doubts in comment section. We'll be happy to help you out. Thank you so much. Thanks a lot.